Okay, this is the May 2020 paper 1 higher number calculator for Edexcel. Let's get into this. Question number 1. This is on arithmetic sequences and nth terms. So to find the nth term of an arithmetic sequence, there is a formula you can have memorized, and this is the formula. So this says that the nth term, that's what the un means, is equal to a, which is the first term, plus n minus 1 times by d. And d is the common difference between the terms. So a is 1, that's our first term. And d is 3, because we're adding 3 every time. So if we put a and d into this formula, then we get the nth term is equal to 1 plus n minus 1 times 3. We can expand these brackets to get 3n minus 3. It's the same as if this 3 was here. Then we can collect the terms. So we have this 1 minus 3 gives us a minus 2. So the nth term is 3n minus 2. Good. Question number 2. This is a really easy fractions question. We want to turn these into improper fractions, so let's first turn this one. The shortcut is to do 3 times 2 plus 1. That's our denominator, and the numerator is just this 3. It's whatever is at the bottom of this fraction. Likewise, for this mixed number, we can do 4 times 3 plus 3, 15 over 4. So that's our improper fraction for 3 3/4. Now we just need to multiply these together. Just multiply fractions, pretty easy. We can make this a bit easier by dividing this 15 and this 3 by 3. So that gives us 7 over 1 times 5 over 4. Just multiply them together. 7 times 5 gives you 35. 1 times 4 is 4. Now we need to turn this improper fraction back into a mixed number, and hopefully we get this. So we do 35 divided by 4, which is 8 remainder 3. Which means that we're going to have 8 3/4 left over, which is what we wanted. Good. Question number 3 then. So these graph questions, you should just have memorized. You should know what these graphs look like by heart. So very quickly, we should know what this one is, because this is a positive quadratic. Positive quadratics have it's like U shape to them. So this one is D. The next one you should just very easily be able to spot is a cubic. So cubics look like this. They're these sort of squiggly shapes. A positive cubic, i.e. the one without the negative, they start at the bottom left and they go to the top right. So this one's very obviously C. The next one should be the negative cubic, which is this one. It's the same shape as a positive cubic, except the negative cubics start in the top left and they go to the bottom right. So that's B. And by process of elimination, we know that this one's going to be 1 over x. So this one's A. You should know what a reciprocal graph looks like just from memorizing it, but you can also just get it from elimination. You can also think of it as, well, we can't divide by 0, so we can't have x equal 0, and this is the only graph where x doesn't equal 0. Cool. Question number 4 then. So we got a bunch of triangles. We want to find out which 2 triangles are congruent. So congruent just means they're the same shape and the same size. So what I would do is just pick A and just compare it with everything else. So if you compare triangle A with triangle B, well, they share an angle, and they share a side, but we don't know what these 2 angles are. They could be anything, as long as they all add up to 180. So we have no way to tell whether these 2 angles, whether these 2 triangles are the same triangle. Well, triangle A and triangle C, well, they share an angle and they share a side, but again, we don't know what these angles are, so there's no way of knowing whether these 2 are congruent. Triangle D is interesting because triangle D gives us 2 angles, which means we can find out the missing one by doing 180 minus 45 minus 80, because the angles in triangle add up to 180. So that gives us 100 minus 45, which is 55. So this angle here, the missing one, this is 55. So if this is 55, well, it shares an angle. We can share another angle, which means that if they share 2 angles, then we know that this one's going to be 80 because they've all got to add up to 180. So they have the same angles, and they also have one shared side, which means that they're congruent. So A and D, they share a side and another side and an angle, which is the condition, but one of the conditions for congruency. Cool. Question number 5 then. Sean pays £10 for 24 chocolate bars. He sells all 24 chocolate bars for 50p each. Work out Sean's percentage profit. So if he's selling 24 chocolate bars for 50p each, well, that means he's basically selling them for £0.50. So if he's selling 24 chocolate bars for £0.50 each, then he's going to make 24 divided by £2, which is 12. So he's going to make £12. his profit is going to be this £12 minus his budget of £10, which is equal to £2. So he makes £2 total profit. We want to find out the profit as a percentage of his original budget. So let's think of it as a fraction first. So it's going to be 2 over 10 because it's 2 over his original. To turn a fraction into a percentage, we just need the denominator to be 100. So we can multiply the numerator and the denominator by 10. That gives us 20 over 100, which is 20% profit. Next question. We have ADC as a triangle. We're given that AED and ABC are straight lines. This line and this line. And we're given two angles here. We want to work out the size of angle EAB. So let's just label that. We'll call it alpha. So in these kind of questions, it's good to just draw stuff that we can find out very easily. The first thing I did was find out the angle EBA. Now, this is quite easy to find out because the angles on a straight line add up to 180 degrees. So this angle here is going to be 180 minus 148, which is 32 degrees. So we can plot that on the graph. So we found out one angle. Let's see what else we can find out. Well, the next easy one is going to be this angle, which is angle AEB. Well, this one is going to be equal to EDC. So this angle here is equal to this one because they're corresponding. Because this is a straight line and these two are parallel, it means that these two angles are going to be the same because they're corresponding angles. So if this is 63, then this is also 63. So AEB is 63. And then we can mark it on. Well, now we've got two angles in a triangle. I mean, we want to find out one of the missing angles. So to find out the missing one, we just do 180 minus these two. So angle EAB is just 180 minus 63 minus 32, which gives you 85 degrees. And you can give the reason that the angles in a triangle add up to 180. Good. This question is about data sets. We got some heights for Year 9 boys and Year 9 girls. The Year 9 girls data is given in this table, and the Year 9 boys is in a stem and leaf diagram. So we want to compare the distribution of heights of the girls with the distribution of heights of the boys. So when we want to compare distributions, what we really mean is we want to compare the range and the median. So let's find the range of the Year 9 girls. So the range is the biggest value minus the smallest value. So the greatest height minus the smallest height, which is 170 minus 150, which is 20 centimeters. So we've got the range for the girls and we've got the median for the girls. So let's find the median for this stem and leaf diagram. Well, to find the median, we need to first find out the median position. We need to find out where the median is. And to do that, we simply take 15, which is the amount that we have. We add 1 and divide it by 2. So that's going to be 15 plus 1 over 2, which is 16 over 2, which is equal to 8. So let's find the 8th item. So 1, 2, 3, 4, 5, 6, 7, 8. So the median is 168. So let's write something down about the two medians. Well, the median for the boys is higher than the median for the girls. So we can write that down. We can say because 168 is bigger than 165. Welcome to GCSE Maths. Now that we've done that, we can compare the ranges. So let's very quickly work out the range for the boys. Well, the range, again, it's the biggest value minus the smallest. Well, the biggest is 182 and the smallest is 158. So the range is 182 minus 158, which is 24. Well, the range for the boys is 24 and the range for the girls is 20. So we can say that the range for the girls is less than the range for the boys, or we can do the other way around. We can say that 24 is greater than 20, and that should be sufficient. Question number 8 is on pressure. So we have a prism that's placed on the surface, horizontal floor. We're given the height is 3 meters, the volume is 18 meters cubed. The pressure on the floor due to the prism is 75 newtons per meter squared. Work out a force exerted by the prism on the floor. So given quite a bit of information here, let's just write down what we know. We know the volume is 18 meters cubed. We're given the equation for pressure. So pressure is equal to force divided by area. So we want to find out just the force. So we can rearrange this equation. We can multiply by the area to get pressure times area is equal to the force. Well, what values do we have? Well, we have the pressure. That's 75. So we put 75 in here. And that gives us 75 times by the area equals a force. So we need to find out the area. Well, what that means is that we need to find out the area of the hexagon. Because what the area means is the area of this face, the thing that's actually making contact with the floor. So we're given the volume is 18 meters cubed. Well, the volume is going to be the area of the hexagon times by 3, because to find the volume of a prism, we just take the area of this cross-section and multiply by the volume. No, sorry, by the height, sorry. So the volume is equal to the area of the hexagon times by 3. Well, the volume we're given is 18. So 18 is equal to the area of the hexagon times 3. So the area of the hexagon is 18 divided by 3, which is 6. So now we have 6 as the area, we have the pressure, we can put this 6 into here to get 75 times 6 equals a force. You can do sort of column multiplication, but I just did that, well, 7 times 6 is 42, so 70 times 6 is 420, and 5 times 6 is 30, and together you get 450 newtons. Cool. Next question, some stuff on standard form. With this question, I just turned them all into decimals. So this first one, 6.72 times 10 to the 5. What this basically means is just move the decimal point 5 places to the right, because we're making this bigger. So if we do that, we get 672,000. And then likewise for this one, 67.2 times 10 to the minus 4. This means just take the decimal point and move it 4 places to the left, because we're making it smaller. So if we move the decimal place 4 places to the left, we get 0.00672. For this one, there's no decimal, so we're just trying to get by 10 to the power of 4. So that just means add on 4 zeros. So we're trying to get by 10,000. So that gives us 672,000. So, wait, is it 10,000? Yeah, whatever. So this next one already given to us as a decimal, so we don't have to change anything. So now they're all in decimal, so it's going to be very easy to start with the smallest. It's very obviously this one, because it goes 0006. This one only goes 006. So this is the smallest. And then it's obviously going to be this one, because this is the only one that's less than 1. It's the only one where it's like 0 point something. Then this one's obviously the next smallest one, because this one has more zeros. And then this one's obviously the biggest. But we need our answers to be in terms of the original ones. So, well, this one was already in terms of a decimal. Then this one was the 1 to the minus 4. And then likewise, we just put this one next. And then this one was our biggest one. So make sure you just put it in terms of the standard form that they gave you in the question. Question number 10, we're given that A over B is equal to 2 over 5. B over C is equal to 3 over 4. Find the ratio A to B to C. So we're given the fraction A over B is 2/5, B over C is 3/4. So the ratio of A to B, we can write that as 2 to 5. Because that's all this fraction really is. Ratio really is just a fraction. The ratio of B to C is 3 to 4. Now, the thing that links these two is B. But B is a 5 here and a 3 here. If we can make the B element of each ratio the same, we can combine them. So we look at this 5 and look at this 3. Well, the lowest common multiple is going to be 15. So to make this 15, we times it by 3. So if we times this entire ratio by 3, we get 6 to 15. Because the 2 times 3 gives us 6, 5 times 3 gives us 15. To get this 3 to a 15, we just multiply by 5. So we multiply the 3 by 5 and the 4 by 5. That gives us 15 to 20. Now the b's are of the same form. We can write this as one ratio. We can 6 to 15 to 20. And that's our final answer. Number 11, just doing some very careful surd manipulation. So if we have something like this, we know from our laws of surds that we can actually split this up. Because if you're multiplying something under a root sign, you can make it into these two. So now that we split it up, this could be a little bit easier. Now the fourth root of 81, you can sort of just guess that it's 3. Or you can sort of think about it logically, because the square root of 81 is 9. Square root of 9 is 3. So 3 is a very reasonable guess. You should kind of just be able to spot it, but you could rewrite this as 9 squared. So then if you're trying to take the fourth root of 9 squared, it just means take the square root of 9 squared and then square root it again, which gives you 3. So now we're left with 3 times the fourth root of 10 to the 8. Well, I'm going to rewrite this. We know from our laws of indices that we can rewrite these roots as fractional indices. So instead of saying 10 to the power of 8 fourth rooted, I can say this is 10 to the power of 8 all to the power of a quarter. Well, again, using laws of indices, I can multiply these two powers to give us 10 to the power of 8 over 4. And 8 over 4 is also 2. So this just simplifies to 3 times 10 squared. Well, 10 squared is 100. So you get 3 times 100, which is 300. Part B, then, we have 64 to the power of minus a half. So if you have a minus, this means that we're doing the reciprocal, which means that we do 1 over this. So deal with the negative first. We have 1 over 64 to the power of a half. So we've dealt with the negative. Let's deal with this fraction. Power of a half means that we take the square root. So this is 1 over the square root of 64, which is 1 over 8. Part C, then, we want to write this thing as a power of 3. Well, let's look at the numerator. Well, that's already in terms of 3, so that's fine. The denominator, well, looking at 9, I can rewrite 9 as 3 squared. So this is going to be 3 squared to the power of n minus 1. And again, using a law of indices, we can multiply this by this power. So we have 3 to the n over 3 to the 2n minus 2. And then, now that we have everything in terms of 3, we can use our laws of indices to say that when we divide powers, we subtract them. So this is going to be 3 to the n minus 2n plus 2, because we're doing minus 2, because the dividing means that we're subtracting. Subtracting a negative is positive. So we get 3 to the n minus 2n plus 2. We can collect these n's to give us 3 to the minus n plus 2, or 3 to the 2 minus n. However you want to write it, it's fine. And that's our answer. Question number 12. The table gives information about the weekly wages of 80 people. We want to complete the cumulative frequency table. So to do a cumulative frequency table, it's basically just a running total. We just add up each thing as we go along. So between 200 and 250, it's going to be 5. We then add a 10 to give us 15. We then add 20 to give us 35. Add 20 again to give us 55. Add 15 to give us 70. And add 10 to give us 80. It's a running total, which makes sense because we get 80 at the end and we have 80 people in total. Okay, so to plot a cumulative frequency graph, what we need to do is we need to find the midpoint of each class and then plot the cumulative frequency. So between 200 and 250, well, very luckily, it's plotted very conveniently. So the midpoint's going to be here. And the cumulative frequency is 5. Between 250 and 300, the cumulative frequency was 15. Between 300 and 350, the cumulative frequency was 35. Between 350 and 400, the cumulative frequency was 55. Between 400 and 450, the cumulative frequency was 70. And between 450 and 500, the cumulative frequency was 80. So now we've got all the points. We just line them up with a bunch of straight lines, and that's our graph. Part C, Joanne says that 60% of this group have a weekly wage of £360 or less. Well, if we have 80 people, we need to think about what's 60% of 80. Well, 60% of 80, well, 10% would be 8. So to find out 60%, we do 8 times 6, which is 48. So we're saying that 48 people have a weekly wage of 360 or less. That's their claim. Well, let's look at 360 as a wage. Well, if we have 50 difference between here and here, there's 10 squares. That means each of these squares represents 20. So 360 would be here. So then we're going to go up on this graph, and it gives us that the cumulative frequency is 51, about 52. So that means that 52 people have a weekly wage of 360 or less. So that's not 48, which means that Juan is wrong. So that's question 12. Question 13, we have some stuff about density. So liquid A and liquid B are mixed together to make liquid C. Liquid A has a density of 70 kilograms per meters cubed. Liquid A has a mass of 1400 kilograms. Likewise, we've got the density and the volume of liquid B, and we want to find out the density of liquid C. So the equation for density is mass over volume. So let's plug in the values for liquid A. So for liquid A, we're given the density is 70. We're given the mass is 1400, but we're not given the volume. That's the unknown value. So let's say the volume is V. I can work out the volume by multiplying both sides. So I get 70V equals 1400. And because 14 divided by 7 is 2, we can say that V is equal to 20. Doing the same thing for liquid B, we're given that the density is 280. We're not given the mass, we're given that the volume is 30. So to find out the mass, we multiply 280 by 30. So we do 280 times by 30. That's 8,400. You can use sort of column multiplication for that if you want to. Or you can do 28 times 3 and then times by 100. So now we have all our missing values. Let's find the density of liquid C. Well, to find the density of liquid C, we need the mass and the volume. The volume is going to be 20 plus 30 because we found the volume of liquid A was 20 and we're given the volume of B, which is 30. So the volume of C is 50. Now we need the mass of C. That's going to be 8,400, which we worked out from liquid B, and plus the mass of liquid A, which is 1,400. That gives us 9,800. So now we find the density of C, which is the mass over the volume. So then we get 9,800 divided by 50. We can divide the numerator and the denominator by 10 to give us 980 over 5. So that is 196 kilograms per meters cubed. You can use sort of bus stop division for that. I just sort of did it in my head. So question number 14. Sally plays 2 games against Martin. In each game, Sally could win, draw, or lose. In each game, the probability that Sally will win against Martin is 0.3. Probability that she'll draw against Martin is 0.1. Work out the probability that Sally will win exactly one of the 2 games against Martin. So let's write down some information. So the probability that Sally wins is 0.3. The probability that she draws is 0.1. We want to find out the probability that she loses. Well, the probability that she loses, well, thinking that probabilities add up to 1, the probability that she loses is going to be 1 minus this outcome. So it's going to be 1 minus 0.4, which is 0.6. So 0.6 plus this gives us 1, so that's all the outcomes. So the probability that she loses is 0.6. So now that we have the probabilities, let's think about the different outcomes. Now you could draw a tree diagram, but I don't like doing those. So let's think about the scenarios where she wins first. So if she wins first, she can then lose the second one. She can win first and then win the second one, or she can win first and then draw the second one. That's all the possibilities about winning first. Now let's try all the possibilities of her losing first. Well, if she loses first, she can win the second one. She can lose the first one and lose the second one, or she could lose the first one and then draw the second one. So those are all the options for if she loses first. Now the last thing is if she draws first. So she could draw first and then win. She can draw and then lose, or she could draw twice. So these are all the possible outcomes. So let's look at the options where she wins exactly once. Well, that's going to be this one where she wins and then loses. It's going to be this one where she wins and then draws. So these two, she only wins once. But also when she loses first and then wins, she wins once. And then when she draws and then wins, she only wins once. So these 4 outcomes are the ones where she only wins once. So we need to find out the probabilities of all of these and then add them up. So the probability that she wins and then loses, well, it's going to be 0.3, the probability that she wins, multiplied by 0.6, the probability that she loses. And that gives us 0.18. The probability that she wins and then draws, well, that's going to be 0.3 multiplied by 0.1, which is 0.03. Now, for these two, we actually don't need to work these out because to lose and then win, it's the same as this probability. It's just the other way around. So this is 0.18. And likewise, drawing then winning is the same as winning then drawing. Because again, they're just the same thing, just the other way around. So this probability is 0.03. Now we add these up to get the total. So 0.18 plus 0.03 plus 0.18 plus 0.03. That's 0.42. And that's the final answer. Question 15 is on coordinate geometry. So the straight line L1 has an equation y equals 3x minus 4. The straight line L2 is perpendicular to L1 and passes through this point. Find an equation of L2. Well, we're given that L1 is this equation. So this is in the y equals mx plus c form. So because the number in front of the x is 3, this is the gradient. So the gradient of L1 is 3. Now we know that L2 is perpendicular to L1. Now because it's perpendicular, that means the gradient of L2 is going to be the negative reciprocal of L1. Because if you want to make a gradient perpendicular, you take the negative reciprocal. And that means that we take the negative flipped version of 3. So we flip it to do 1 over 3, and then we make it negative. So minus the third is the gradient of L2. So L2's equation is going to look something like this. Y equals minus a third x plus c. Now we want to find out what the c value is. And to do this, we can just plug in any point on this line. Well, it gives us 9, 5. So we put y equals 9, x equals 5 into this. We get 5 equals minus a third times 9 plus c. The 9 and the 3 will divide to give you minus 3. Add the 3 to both sides, you get c equals 8. So if c equals 8, we can put that back into here. So y is equal to minus a third x plus 8. Cool. Question number 16. This is one of those capture-recapture questions. You've kind of just got to know how to do these by heart. So Shirley wants to find an estimate for the number of bees in her hive. On Monday, she catches 90 of the bees. She puts a mark on each bee and returns them to the hive. On Tuesday, she catches 120 of the bees. She finds that 20 of the bees have been marked. And I want to work out an estimate for the total number of bees in her hive. So let's look at Tuesday's information. So if you think about the ratio of the bees that were caught to the ratio, to the number of the bees that were marked, well, she caught 120 and 20 of them were marked. Okay, well, now let's think about Monday. She marks 90, but we don't know what the total was. So it's 90 out of what? That's what we're trying to figure out. So as a fraction, the number of marked to the number of them that were caught on Tuesday is 20 over 120. So 20 out of 120. On Monday, the number of them that were marked as a fraction of the total is 90 over the total. We don't know what the total is. That's what we're trying to figure out. So now we just want to find out what this value is. So we can solve this by, well, first of all, we can simplify this fraction by dividing the numerator and the denominator by 20. Or you could divide them by 2 repeatedly if that's easier. So you get 1/6 is equal to 90 divided by the total. To get the total on its own, we just cross multiply. So the total is equal to 90 times 6, which is 540. Part B then, Shirley assumes that none of the marks had rubbed off between Tuesday and Wednesday. If Shirley's assumption is wrong, explain what effect this would have on our answer. So let's think about it. If the marks had rubbed off between Monday and Tuesday, then less bees would have been marked. So let's say hypothetically, instead of finding 20 bees that have been marked, let's say she found 10. So then we'd have 10 over 120 is equal to 90 over the total. And so if we did the calculation again, we simplified and we cross-multiplied, the total would be 90 times 12. Well, that's going to be more than 90 times 6. So that means that if then marks off, well, it's clear that whenever the markings come off, we tend to overestimate the answer. So if less bees are marked, then the answer would be an overestimate. You don't have to do this calculation. I just did this to show you why it'd be an overestimate, because if you make this number smaller and you do the rest of the calculation, the total ends up being bigger. Cool. Question number 17. We want to make f the subject of this formula, so that means get f on its own. So the first thing we could do is expand these brackets. So we multiply everything outside by everything inside. So we have 3 times 1 minus 3 times f. So that would give us 3 minus 3f over f minus 4. Now we can multiply this f minus 4 onto this side to give us d times f minus 4 equals 3 minus 3f. We can expand the brackets, so d times f minus 4d is equal to 3 minus 3f. Now, we want f on its own, so if we put everything with f on one side and then everything without the f on the other side, we can add the 3f to this side and add the 4d to this side. So everything with f is now here. So we get df plus 3f equals 3 plus 4d. We can take a factor of f out to get f brackets d plus 3. So we just factorize this. If you expand this out, you get f times d plus 3 times f, so this works. That's equal to 3 plus 4d. To get f on its own, we can divide both sides by this bracket. So we get f is equal to 3 plus 4d over d plus 3. Okay, cool. For this question, we're saying that x is proportional to the square root of y, where y is positive. Y is increased by 44%, so we want to work out the percentage increase in x. So we can say that x is proportional to the square root of y. So if y is increased by 44%, then let's think about our percentage multiplier. Well, the multiplier is going to be 1.44 because it's 1 plus 44%. So if our new x value, let's say it's x2, that's proportional to the square root of 1.44y because it's proportional to y. We've increased y by 1.44, so this is obviously our new formula. Well, We can split this using our knowledge of surds to say that x2 is proportional to the square root of 1.44 times the square root of y. So now this looks a bit more like our first thing because we've separated the root y. So the increase is this square root of 1.44. Well, the square root of 1.44, that's actually quite easy to figure out because the square root of 144 is 12. So the square root of this thing is 1.2. That should be a proportional sign, not an equal sign, but I'm too lazy to change it. So that means that x is being increased by 1.2. So an increase of 1.2 is the same as 20% because the 0.2 is 20%. Cool. Question 19, some stuff about functions. We're given that f of x is 12 over the square root of x and g of x is this thing. We want to find g of 5, so this just means that set x equal to 5 and just solve it. So g of 5 is equal to 3, 2 times 5 plus 1, so putting 5 into here. This 2 times 5 gives us 10, so we get 3, 10 plus 1. We can add the 10 and the 1 to give us 11. So we get 3 times 11, which is 33. Part B, then we want to find g f of 9. So what this means is find f of 9, so put 9 into here, and then take whatever value that gives you and put it into g. So let's first find f of 9. That's going to be 12 over the square root of 9, which is 12 over 3, which is equal to 4. So that's what f of 9 is. Now we need to put f of 9 into here. So we put 4 into here. So g of 4 is equal to 3 brackets 2 times 4 plus 1. That gives you 3 times 9, which is 27. So we can write our final answer as g f of 9 is equal to 27. Part C then, find g inverse of 6. So one way you can think about this is when we say find g inverse of 6, we're saying what value of x do I need to put into this function to give me 6? So that means that what value of x would give me 6 if I put it into here. So I can take this thing, the 3 2x plus 1, and make it equal to 6. And if I solve this for x, then I find the inverse of 6. So I find the g inverse of 6. So I can expand these brackets to get 6x plus 3, that's equal to 6. We can take 3 from both sides, divide it by 6, we get x is equal to a half. So that means that g inverse of 6 equals a half. Well, this means that if you took a half and put it into this, you'd get 6. Question number 20. This question's not that difficult, it just requires a lot of very careful surd manipulation. So we want to write this horrible looking thing in the form a plus root 5 over b. So a and b are integers, so they're not square roots, they're not surds or anything. So in a question like this, it's going to be pretty obvious we're going to have to rationalize it because we want to get rid of this square root on the denominator. So to rationalize a surd, we just multiply the fraction by what we call the conjugate of the denominator, which basically just means take this thing and change the sign. So we just multiply it by 5 root 5 plus 5, which gives us this, just using the brackets notation. Now, this looks quite horrible, but we can make this simpler because, well, think about the question. Everything's in terms of root 5, apart from this square root of 180. So let's see if we can simplify this surd anyway. So the square root of 180, that's the same as the square root of 18 times by the square root of 10, just using our laws of surds. Well, the square root of 18 is equal to the square root of 9 times by the square root of 2. Well, the square root of 9 is 3, so the square root of 18 is just 3 times root 2. And then we can do the rest of the multiplication to get 3 root 2 times by these two things. Well, 3 root 2 times root 2, well, the roots multiply to just give us 2, because when you multiply two square roots, you just get the thing inside it. So that would give us 3 times 2 times by root 5. So 3 times 2 is 6, so that gives us 6 root 5. So instead of saying square root of 180, I could say 6 root 5. Well, 6 root 5 minus 2 root 5 is 4 root 5. So I can rewrite this thing like this. And this is a lot easier to work with. So if we expand these brackets, we get the 4 and the 5, that gives us 20. And the root 5s will multiply to give us 5, so we get 20 times 5. Then this 4 and this 4 multiply to give us 20, so that means we get 20 lots of root 5. The denominator, you just multiply these two, so that will give you 25. These roots multiply, so we get 25 times 5, plus this times this, so 25 root 5, minus 25 root 5, so these will cancel, and then we get a minus 25 from these two. So 20 times 5, that's 100, so we get 100 plus 20 root 5. The denominator, well, these two things cancel. We just get 25 times 5 minus 25. Well, 25 times 5 is 125. You minus 25, you get 100. So we get this. We want it to be in this form. So you have to split this into two different fractions. So you have 100 over 100 plus 20 root 5 over 100. Well, 100 over 100 is 1. The square root of 5 over 5, well, we just get that because we can simplify this, so divide the numerator and the denominator by 20, so we just get 1 over 5, and that's our final answer. Question number 21, this is one of those horrible vectors questions that no one likes. I'm going to try and show you the general method for doing these questions, and hopefully you can sort of just pick up how you're meant to think about vectors, but these questions are difficult. So we're given a triangle, we're given that P is the midpoint of this line, Q is the midpoint of this line. We're given that f to d is equal to a and f to e is equal to b. Use a vector method to prove that p to q is parallel to fe. So let's first draw some stuff on this diagram. Well, if f to d is equal to a, and this is the midpoint, that means that this section here, f to p, is a half a. And f to e we're given is b. And we want to prove that pq is parallel to fe. Well, let's draw on PQ as a dotted line. We need to prove that this thing is parallel to this thing. And to prove that things are parallel, we need to prove that the PQ vector is a multiple of the FE vector. And the reason that proves it's parallel is because a vector is a magnitude and a direction. It's a size and a direction. So if they're multiples of each other, it means that they're going the same direction, they're just different sizes. And going the same direction means that they're parallel. So we need to prove that this dotted thing is a multiple of this thing. Okay, well, let's try and add some more stuff to the diagram. Well, if this is a half a, this is also a half a. So now I've got some vectors to work with. So logically, the question is asking about PQ, so let's try and find what PQ is in terms of vectors that we know. Well, how can we get from P to Q? Well, we can go down here, through here, up here. That seems quite reasonable. So we can say that P to Q is minus a half a, because we're going down, plus B, plus E to Q. Okay, well, that's one way we can get P to Q. What's another way we can go? Well, we could go down here and then up to FQ, but we don't know what F to Q is, so that's not that reasonable. However, we can go from P to D and then D to Q. Well, P to D is a half a. And D to Q, well, if Q is the middle of this straight line, then E to Q is the same as Q to D. So to go from here to here is the same as going from here to here. So what I'm saying is that instead of saying I'm going from D to Q, I can just say I'm going from minus EQ because I'm just going down. So this thing is also just EQ because it's the midpoint. So to go from P to Q here, I just go a half a minus DQ. Sorry, plus DQ, but DQ is the same as minus EQ. I hope I haven't confused anyone there. So now we have two equations for P to Q. Very logically, the thing to do here is to equate them. So I get this thing. I just take this, make it equal to this. I can add the half a's to both sides, and I can also subtract the b from both sides. That gives me a minus b equals 2 times EQ. To get EQ on its own, I can divide these two by 2. To get a half a minus a half b equals EQ. Well, this is good because now I have EQ in terms of vectors that I already know. So if I take this EQ and plug it into one of these, hopefully it gives me P to U in terms of just A and B. Well, if I put this into here, I get this. So I get the minus a half a plus b plus a half a minus a half b. Well, the half a's will cancel, and I'll just be left with b minus a half b, which is a half b. So P to Q is a half b. Well, b is just F to E. So I can say that P to Q is a half of FE. So that means that these two are multiples, right? This thing is half of this thing. So that means that they're parallel because they're multiples. And that's all you have to do. My recommendation in these kind of questions, because if you think about it, this was the hard part. Once you've done this, you just equate them and then plug it back in. My advice would just be write stuff down. Just write vectors in terms of things that you know. And just eventually you'll draw enough stuff that something will click. That's generally how these vectors questions go. Question 22. This question is quite difficult. The diagram shows two shaded shapes, A and B. So we get shape A by removing a sector, so a slice of a circle with the radius 3x minus 1 from the sector of a circle with the radius 5x minus 1. And then shape B is a circle of 2 minus 2x centimeters. We want the area of shape A is equal to the area of B, whatever, find the value of x. Okay, well, the question gives us a ton of information, so let's just see what we can do with it. Very logically, the first step is to find the area of A. So the area of A is the area of this big sector minus the area of this small sector here. So let's find out the area of sector 1, which I'm saying is the big sector, the one in total. Well, the sector is just a slice of a circle, so we need to find out how much of a slice it is. Well, the angle in a circle is 360 degrees, and the angle of this sector is 45. So we do 45 over 360 is 5 over 40, which is an eighth. So this is an eighth of a circle. Well, the area is usually pi r squared for a circle, but for this sector, it's going to be 1/8 pi r squared, because we're only taking a section of it. Well, the radius is going to be 5x minus 1, because we can do this plus this. So 3x minus 1 plus 2x is 5x minus 1. So the area is going to be an eighth times by this r squared. Well, we can expand these brackets, and you can expand them out just by hand. I just did it in one step. That gives you 25x squared minus 10x plus 1. So that's the area of this entire thing. So let's find the area of this small sector, and then hopefully using that we can find the area of A. So the area of sector 2, well, it's going to be, again, 1/8 pi r squared. Well, r in this case is 3x minus 1. That's the radius of the small sector. Likewise, we can just expand these brackets. So we get 1/8 pi 9x squared minus 6x plus 1. So this is the area of the small sector. This is the area of the total big sector. To find the area of A, I just do this minus this. So I get this. They both have an 1/8 pi, so I can take that to the front and I can just focus on subtracting these quadratics. So the 25 and the 9, they'll subtract to give me 16x squared. The minus 10 minus 6 will give me minus 10 plus 6x. So that'll be minus 4x, and the 1's cancel. So this is the area of A. Okay, well, now I've got the area of A, let's find the area of B. Well, we need to find the radius of B, but it gives us the diameter. So the radius is going to be the diameter divided by 2. So the radius of B is 1 minus x. And so the area of B is going to be pi times by r squared, r being 1 minus x. Again, expand these brackets, we get x squared minus 2x plus 1. So this is the area of B, this is the area of A. We can equate them because we're told they're equal. This looks quite horrible, but we can make it easier. We can get rid of the pi's, so we can divide both sides by pi. We can multiply both sides by 8 to get rid of this fraction. So then we can expand this bracket by doing 8 times everything inside of here. That gives you 8x squared minus 16x plus 8. And then we can take everything to one side. And so we do 16x squared minus the 8x squared. That gives you 8x squared. We have the minus 4x plus the 16x. That gives us 12x. And then the minus 8 goes here. Now we have a quadratic. Well, we can simplify this quadratic by dividing by 4. So that gives us 2x squared plus 3x minus 2. Well, now we just have a quadratic in terms of x. So all we need to do is solve this quadratic. So we can use a quadratic formula, which is this. I'm pretty sure this is given to you in the formula book. A is equal to 2, B is equal to 3, C is equal to minus 2. Just plug those values in. Just be very careful. You can condense this thing to 9 plus 16. That gives you minus 3 plus or minus the square root of 25 over 4. So then the square root of 25 is 5. So this is our two values of x. If we do minus 3 plus 5 over 4, that's 2 over 4. If we do minus 3 minus 5 over 4, that's minus 8 over 2. But because we're dealing with areas, x can't be negative. So this is the only value we can have. So x is equal to 2 over 4, which is also equal to a half. Pretty tough question. I think this is the last question. There are 4 types of cards in the game. Each card has a black circle or a white circle, or a black triangle or a white triangle. We're given the ratio of the number of cards with a black shape to the ratio of number of cards with a white shape is 3 to 5. Number of cards with a circle to the number of arms with a triangle is 2 to 7. Express the total number of cards with a black shape as a fraction of the total number of cards with a triangle. Okay, a lot of information here. So express the total number of cards with a black shape as a fraction of the total number of cards with the triangle. So let's find the fraction of cards with a black shape. Well, the ratio of black to white cards is 3 to 5. The ratio of the cards with a circle to the ones with a triangle is 2 to 7. So let's find the fraction of cards with a black shape. Well, if the ratio is 3 parts to 5 parts, we have 8 parts in total. 3 of those 8 parts are black cards, so 3/8 of the cards are black. Now let's find the fraction of cards with the triangles. So the ratio is 2 to 7. That means we have 7 plus 2, which is 9 parts in total. 7 of the 9 parts are going to be triangles. So 3/8 of the cards are black. 7/9 of the cards are triangles. We want to find the total number of cards with a black shape as a fraction of the cards with a triangle. So we need to find this as a fraction of this, a fraction of a fraction. Now that's quite horrible to look at. But think about what a fraction means. It's just the numerator divided by the denominator. So it's 3/8 divided by 7/9, which dividing fractions is very easy. We just flip the second and multiply them. 3 times 9 is 27. 8 times 7 is 56. And that's your final answer. That's all the questions. Thank you very much for watching. See you next time.